Let's talk a little bit about homework 2. As usual, you can find all of the information that you'll need about it through the assignment on Canvas. I've got open already the homework description, the Mimir, and the API documentation, which you'll be able to find from the link that's in the homework description document. Homework 2 centers on this idea of a client-server application where the server coordinates some computational work that needs to be done across multiple clients. So it's a distributed sort of application. You'll probably mostly run the server and the clients all on the same machine, but the model is one where the server runs on one machine and then many different people have the client installed so they can do some of the work. Models like SETI at home or folding at home are examples of this kind of thing, where there's some large amount of work that needs done, and many different computers do that work by having a client running. So to do the work that you're going to need to do here, you're going to need to be able to serialize some data and send it across your connections between the server and the client. To do that, you'll write a few different serializable data structures. A serial list, for which you have some starting code available through the serialization notes. It won't perfectly match, but it's relatively close and should be adaptable, and you're welcome to do that. A serial binary search tree, and a serial priority queue. I may put out some starting code for each of these, but you're welcome also to design them and start them yourself, as long as they match the API documentation for those classes. So all of these, the key to them will be that they'll be serializable. You'll be able to turn them into bytes and then send them across the network connection from the server to the client and possibly back again. The things that you'll be practicing for this assignment are connections with sockets, using threads, because there will be multiple threads running for the server, I/O streams, reflection, and serialization. Reflection will come in the form of you being told what methods need called on the data structure. The client will be told what methods need to be called on that data structure, and it will be the client's job to use reflection to call those methods. So the server gets some list of jobs from a file input, typically, and it adds work to its data structure that holds those different tasks. Then it listens for connections from clients. When a client connects, then an eval connection object will be created specific to that client, which is responsible for passing work to the client and getting the results from the client. These will run in their own thread for each client, so you may have multiple clients connected at a time. Then the results will be stored in some central data structure belonging to the eval server. The getWork method will be used by the eval connection to get one of those tasks to hand to the client. It should remove the task from the list of all tasks in a synchronized fashion, meaning that it's safe for the multiple different threads to interact with that list. There are many different data structures in Java that are already written to be thread safe or synchronized. You'll want to make sure that you use those for the data structures that store your tasks and that store your results, because your results may be coming in many at the same time from those different clients. There's a simple Boolean has work that will indicate whether there is work left or not, so that clients know if it's worth their time to stay connected. When all clients are disconnected and there is no work left to be done, then the server should shut down. The Eval Client is sort of similar. It has an initialization. It will connect in that initializing step to the server, and then it will check whether there is work to do by calling has work. If it's true that there is work, It does not call has work, by the way. It sends a query across the connection that states has work. And then the eval connection will turn that into a call to has work from the server and return back to the client true or false. If there is work, it will get that work and then it will do it and send the results and repeat that process as long as there is work available. When the server no longer has work for the client, or if the socket gets closed, for instance, if the network connection is lost, then the client will just shut down. So, as I mentioned before, to do this work, you'll need several serializable data structures, a list, a binary search tree, and a priority queue. Make sure that when you implement the serialization for these, you do it in a way that's as efficient as possible in terms of memory and computation. You will not be able to write these as generic classes because we're going to create them at runtime and use reflection on them. We will not use generic parameters for them. We will guarantee that the key or the priority for the priority queue is something that implements the comparable interface, which is many, many different built-in classes in Java, and that the data, the values, will be of any object type. So we know that we need our keys to be comparable so we can do things like sorting or prioritizing or organizing a binary search tree. Our data has no such restriction. Then the data, the input for the server will look something like this. It will say what type of data structure, what the key or priorities type will be, and what type the data or the values will be. Then it gets pairs of key and data or priority and data separated by the and character. You can see that down here. I did this so that you can use spaces and other punctuation in your data, but you won't be able to use the and character. Then it's given the method name to be executed and the list of parameters as pairs, the type, then parameter, each separated by the and character again. So here, for instance, we have an example one with two data structures described. This is what your sample input file that you'll get in the starter code has in it. It says there will be a serial BST with integers as keys and strings as values. And then you see those integer string pairs down here. It says you're going to need to call find with the integer 13, which will, by the way, fail because none of these keys are 13. And balance with no parameters. These do not have to be valid method calls, by the way. Both of these are technically valid in terms of the types of parameters. Find will throw an exception because that key is not found. You will sometimes be given ones that have invalid parameters or that are a bad method name or things like that. And you will need to check that as you use reflection to try to call them in the client. And then we have a list with some data, string to string, and that we see those pairs. It will call remove, the string name 3, and it will call sort. And so these will be passed over to a client, and then the results passed back to the server. And that's what our application will be doing. Because all data will be read in as strings from text files, we'll limit ourselves to only the types of data that have a constructor that can take a string as their only parameter. So it's your job to check to make sure that such a constructor does exist for the type that you're trying to create. But we will, for our intended purposes, limit ourselves to things like integer has a constructor that you can say new integer and give it a string with the number 3 in it or that kind of thing. And you can create strings from strings as well. And there are other types of Java data types that you can use that have a string-based constructor. So let me show you a little bit about the program running and how it would execute. You can get the starter code from Mimir, or you can get the starter code from my website. I will try to keep those in sync and make sure that they're the same. But what you'll notice is that the starter code only contains the sample tests and this one sample input file. I'll make my directory structure for the packages just so that I'm ready with that. And then I'm going to go ahead and cheat a little because I have a solution written up. And I'm going to steal that code so that I can show you how it runs. Of course, you shouldn't do this. You won't be able to do this. Make sure it's copied. Okay. I'm going to open 2 terminals in this same directory because I'm going to need to run the server and the client. I need to go up 1 directory so that I'm in the right spot. Okay, so then I need to compile everything in the eval directory. And then I should be able to run the server. So the command to run the server is java eval server. And then we have to tell it a port number to run on. I'm going to say 8080, which is usually a free port. Not all ports will be usable, so pay attention to that. And I'm going to give it the sample input.txt. And here we have the eval client, eval.eval client. I need to give it the server address. Usually, localhost should work. If you find that's not working on your machine, you can also do 127.0.0.1. One or the other of those should work just fine for you. It may vary based on operating system. You won't see a lot of output from these at the moment. The only output you see on mine is that there was a bad invocation. This is the one I warned you about, where we called find with a key that didn't exist, and we got an exception. That's part of the specification for find for that data structure, is that it throws an exception. So what I'm going to do is I'm going to pause recording for a moment, and I'm going to have my server print the results. In what you submit, you probably should not have your server print the results. It will just store them in a list, and my tests will check that list. But for a moment, I'm going to have it print so that you can see the results coming back. All right, I modified it. It should hopefully still compile and run just fine. And then when I run with the client, and again, I could have multiple clients connecting. There's not enough work for me to really have time to connect multiple clients on this one. But with bigger data structures, for instance, my tests will automatically generate very large data structures rather than reading them in from a file, and then we'll feed those to your server. For those, I'll be able to connect multiple clients. You can generate some files and connect multiple clients as well. Okay, so here we see the bad invocation is actually what was returned as the result as well to the server. The result for the second operation, which was the balance call on the binary search tree, gives us back a different binary search tree, presumably, than the original one that was read in. It's rebalanced. You can see ferret is in a slightly different location maybe, or different things like that. And I don't remember what order of traversal this is, but you can look it up in the spec. Here is the result from remove, string name3 matched to last, and so we got the result of last from that. And then we have sort, which sorted our list. It turned out our list in this case was already sorted because it's sorting by key, but the server got that result back. Now remember, as I said, you may not want the server to be printing out these results. It will slow down your execution on the test, and it may cause you to time out on some of the larger tests when I run them. So again, the main premise of this assignment is to have this client and server application that shares work, possibly across many different clients, and it does so using serialization. These data structures shown here, or this data shown here, is not serialized. This is text input, which is less efficient than good serialization. They would be serialized if they were turned into bytes and then saved to a file or sent over a stream, and those would not be readable to a human. And we can use more compact representations for those. But you will use serialization inside your program to ship data back and forth, and you will use reflection to be able to call methods that are named in the task using the correct parameters and verifying that those methods actually exist, and then passing your result back from the client to the server. Good luck.